Hi there folks, this is the Unit 8 review and I am the amazing Mr. Jansen. So away we go. If we look at these first couple, it asks us to write it in descending order, also known as standard form, sometimes we'll call it that. Then identify the degree, name the polynomial. Alright, so if we look at something like this guy, descending order or standard form is when we list the exponents from least to, biggest to smallest, from greatest to least. And so this one, like this, has an exponent of 1, this guy's got an exponent of 2, and then when we see the 5, that's got an exponent of 0. So I want to list this as 2x squared, then the plus 3x, then the minus 5. Now it's in that standard form. Identify the degree. Really, when it's a polynomial, I just look for the biggest exponent. This one has a degree of 2. And then in terms of naming it, there are 3 terms, so this is a second degree trinomial. And usually we'll kind of list it that way. Instead of saying degree 2 or whatever, we'll say second degree trinomial. It's just a nice succinct way of labeling this thing. Okay. The next one, again, we want to put this thing in descending order, biggest exponent to smallest exponent, so it's a negative 2x to the 6th plus the 4x cubed. And now looking at the degrees here, it looks like the biggest exponent is the 6th, so this is a 6th degree. There are 2 terms, so it's a binomial. And really, it's just a matter of knowing the terminology here. The last one, there's only 1 term, so relisting it in a different order isn't really possible. There's only 1 term to list. But now when I have a monomial, when I have more than 1 variable, I have to add up the exponents, so there's an exponent of 1 here. So this actually has a 3rd degree. And just always be aware of that when you're looking at monomials. That's a 3rd degree. Again, monomial because it's 1. Okay. That's it. If I look at the next one here, it says to add or subtract the polynomials. Addition is really easy. We just start combining like terms. So when I look at this guy, again, to be like terms, they have to have the same variables, the same exponents. So these guys are like terms, the 3x squared and the 5x squared. These guys are like terms. They're both x terms. And then these guys are like terms. They're both constant terms. Okay. So again, we just combine these like terms. When I add them together, you don't do anything. The variable part stays the same, so you don't do anything with the exponents. So a 5x squared plus a 3x squared, I add the coefficients. That's an 8. And then it just stays as an x squared. Same thing next one, the 3x and the 4x. You add the coefficients. That's a 7. The x stays as an x. The negative 6 and the negative 8 is a negative 14. And that's it. All right. With subtraction, again, with subtraction, I always would distribute that negative sign. So if I change this to addition, I distribute the negative sign. Now that's a negative 5x cubed, a minus 4x squared, and a plus 2. Okay, so I distribute that negative sign. Now it's an addition problem, just combining like terms. So I always look for the biggest exponent first. I notice this guy, the 5x cubed, it's all by itself. So the negative 5x cubed doesn't have anybody to add to it. The x squared terms are alike, so I can combine these guys. This guy doesn't have any like terms, and then these guys are like terms. So I just kind of go in descending order and then say, okay, the 2x squared and the negative 4x squared is a negative 2x squared. The negative 3x doesn't combine with anything. It stays the way it is. The negative 7 plus the 2 is a negative 5. And that's it. Okay? So change subtraction, adding the opposite, and then combine like terms. This one, just using our distributive property, whatever's on the outside of parentheses, I'm going to distribute it to everything that's in here. So I distribute it to each of those, just using some of my rules of exponents as I go. So here I do the multiplication. That's a 6x to the 5th. I multiply the coefficients. I add the exponents when I'm multiplying. Here that's a negative 15x to the 4th. Again, there's a little 1 here. So I multiply the coefficients, add the exponents. Here I multiply. That's an 18x cubed. There's no exponents to add to it, so it stays the way it is. All right. Here, same thing. I'm going to use my distributive property. I just have to do it twice. Here, I distribute the 4x. Here, we have to be really careful. I distribute that as a negative 2. Always include the sign that's in front of the whatever value it is as you distribute. Include that sign when you distribute that thing. Okay. So here, I get a 12x squared plus 8x. When I distribute the negative 2, it gives me a negative 10x and a plus 2. And now these two in the middle are like terms, so I'm going to combine those. That's a minus 2x. And that's it. Okay. The next one, same kind of thing. I'm going to do my distributive property. This one's just slightly more challenging in terms of my rules of exponents, just because there's more to deal with. But again, I multiply the coefficients, add the exponents. That's going to be a 6x squared y to the third. Again, that xy each have an exponent of 1 for that 3xy. Here that's a minus 12x cubed y cubed plus that looks like a 9x squared y squared. And that's it. Okay, distributing, multiplying the coefficients, adding the exponents. The next one we have to distribute or FOIL. If you're doing FOIL, it's the first, outside, inside, last. Either way, we're going to do this in the same order. I would just think of it distributing each term. So I'm going to distribute the 3x to each of these, and then I'm going to distribute the 2 to each of these. Okay. When I distribute the 3x, that gives me a 15x squared and a minus 9x. When I distribute the 2, that gives me a 10x and a minus 6. And now I just combine like terms. That's a 15x squared plus x minus 6. Okay. Next one, same kind of thing. I'm going to use my distributive property or FOIL. And so I distribute the 2x, then I'm going to distribute that as a negative 4. And again, be careful with the signs as you do that distributing. So I distribute the 2x, that gives me a 2x squared minus 10x. When I distribute the negative 4, that gives me a negative 4x plus 20. And now I combine like terms. Okay. This one, same kind of thing. I distribute each of these terms. So I'm going to distribute the x to all 3 of these things. And then I distribute the negative 3 to all 3 of these things. And I just write down what I get. So here we go. I distribute the x. X times 2x squared is a 2x cubed. X times the negative 2x is a negative 2x squared. X times the 7 is a plus 7x. Okay? And now again, that minus 3, I'm distributing as a negative 3. So negative 3 times the 2x squared is a negative 6x squared. Negative 3 times the negative 2x is a plus 6x. And then negative 3 times the 7 is a minus 21. And now I combine like terms. The negative 2x squared and the negative 6x squared is a negative 8x squared. The 7x and the 6x is a 13x. And the minus 21 just kind of tags along for the ride. All right? For this one, anytime we're squaring a polynomial like this, we always want to write it that many times. So if it's 2x minus 6 squared, I want to write it as 2x minus 6 times 2x minus 6. And now it's just like the problems we were just doing. I have to use my distributive property or FOIL for this one. I'm going to distribute the 2x, and then I'm going to distribute a negative 6. So again, just be careful as you distribute here. 2x times 2x is a 4x squared. 2x times the negative 6 is a negative 12x. And then as I distribute the negative 6, again, I'm distributing a negative here. That's a negative 12x. And then negative 6 times negative 6 is a plus 36. And now combine like terms. And again, be careful with signs here. Negative 12x minus 12x is a minus 24x. And then the plus 36. And that's it. This guy, same kind of thing. Always rewrite it as 3x plus 2 times 3x plus 2. And now we have to distribute or FOIL. I distribute the 3x to each term. I distribute the 2 to each term. 3x times 3x is a 9x squared. 3x times the 2 is a plus 6x. 2 times the 3x is a plus 6x. And 2 times 2 is the 4. And again, combining those like terms. Okay, that gives me a plus 12x and a plus 4. Next one, once again, is the same kind of thing. We're distributing each term. So I distribute the 3x to each one, then I distribute the negative 5 to each one. Again, just be careful with the signs. Make sure you're distributing the negative. So here that's a 9x squared plus the 15x, distributing the 3x. Now I distribute the negative 5, which gives me a minus 15x and a minus 25. And now as I go to combine like terms, I should notice right away that the negative 15x and the positive 15x, those just kind of completely cancel each other out. They give me a 0 here in the middle. So all I'm left with is a 9x squared minus 25. And that's one of those things that always happens when we're multiplying conjugates. Remember, conjugates, these are conjugates because they're the same binomial with a different sign in between. When we multiply conjugates, the middle term always cancels, okay? And that works both ways, you know, when we see the answer I get is a difference of squares, which goes to factoring a little bit later, okay? Here we want to find the volume. Volume is just length times width times height. And it doesn't matter what order you do those things. So basically, if I've got my length and my width and my height here listed as these guys, I just multiply those three things together. So I'm going to do the 2x times the x plus 2 times the 2x plus 2. All right? And again, it doesn't matter what order we do it in. I prefer always to multiply the binomials first when I'm in this situation. So I'm going to distribute the x and then distribute the 2. So here that gives me an a 2x squared plus 2x plus 4x plus 4. And now I combine like terms. Again, that's a 2x times. That's going to be a 2x squared plus 6x plus 4. And now I do my distributive property with the thing that's on the outside. So I distribute that to all three terms. And that gives me a 4x cubed plus 12x squared plus 8x. And that's it. Okay, so again, we just kind of do our distributive properties, but we're doing both of them at the same time here, and we just kind of take it one step at a time, all right? And again, I always do the binomials first. Not that you have to do that, but I think it's just a little bit easier that way, all right? This one, same kind of thing. Doesn't matter what order we do these in, so I'm just going to write down 3x minus 1 times the x plus 2 times the x minus 2. Again, I can do this in any order. I prefer to start with anything that looks a little simpler. So like here, I'm going to do the x plus 3 times the x minus 2. Not that I have to start with that. I can start with any one of these two, but I just kind of have to take it a step at a time. So here I'm going to do my distributive property. The 3x is just kind of tag along for the ride for a second. But here I distribute the x, that's an x squared minus 2x. When I distribute the 3, that's a 3x minus 6. And now as I combine like terms, that's a 3x minus 1, just tagging along for the ride. That's going to be an x squared plus x minus 6. Well, now it's like one of the complicated ones that we had a little bit earlier. I have to just use my distributive property to distribute the 3x to each of these terms. Then I distribute the negative 1 to each of these terms. So here when I distribute the 3x, that's going to be a 3x cubed plus 3x squared minus 18x. When I distribute the negative 1, that's a negative x squared minus x and a plus 6. Okay? And now it's just combining like terms. I've got the 3x cubed. It's going to be a plus 2x squared, a minus 19x, and a plus 6 as I combine the like terms. Okay? But again, we're applying the same things that we just did, but we're doing it in 2 steps this time, is really all this question is asking us for. Okay? These factoring out the GCF, factoring out the greatest common factor. Again, we just look at the numbers first. So like when I look at a 4 and a 2, the biggest thing divides evenly into each of those is a 2. And most of us are okay with that. But then when you look at the x's, literally think physically about the x's here. If I have 2 x's here, and I have 1 x here, and I say, okay, I want to take the same number of x's away from each of them, the most I could take away is an x. Okay? And then do the same thing with the y's. Physically think about the y's here, and say, okay, I've got a y squared, which is y times y, and then a y to the first, which is just a y. And then say, okay, let me think about what I can take away. I have to take the same number away from each. The most I could take away is a y. All right? And so that's kind of how I identify my greatest common factor. Now when I divide it out, the numbers are easy. Once again, the numbers are easy. I say if 4 divided by 2 is a 2. In the next one, 2 divided by 2 is a 1. I can go ahead and write that down. And then when I think about the x's and the y's, so let's go back up here and physically think about taking these away. If I take one of the x's away from each of these, you see that I'm left with an x with the first term, but nothing with the second term. And if I do the same thing with the y's, I say, oh, let me take one of these y's away from each of you. You see that I'm left with one of the y's for the first term, but nothing for the second term. Okay? And so my answer just becomes this thing of 2x times 2x minus 1. And that's it. Okay? So think about physically removing the variables here. All right? When I look at the next one, between 3, 12, and 9, I can divide out a 3 evenly. And then again, if I think about the x's, I've got an x in this term, an x in this term, and nothing in the third term. It's kind of blank. So I say, can I take an x away from each? And the answer is no, because this guy doesn't have one to give. And when I look at the y's, I've got a y squared. So there's 2 y's here. There's a y here and a y here. If I take the same amount away from each of them, what I can take away is a y. So my greatest common factor is 3y. And then as I divide this out, again, think it back over here. Maybe I'll start with the variable and say, hey, if I take a y away from each of these, you see that I'm left with 1 y for the first term, but nothing for the other terms. Okay, so nothing else is going to change. We just say, okay, 3 divided by 3 is a 1. There's an x left. There's 1 y left. Okay, 12 divided by 3 is a 4, so it's a minus 4. There's an x left, but no y's left. And then the last one, 9 divided by 3 is a 3. The only y that was there has been taken away, so it's gone. Okay? That's it. Next one, same kind of thing. Greatest common factor. I look at the 15 and the 25 and say, okay, I can take a 5 out. And then again, physically thinking about the x's, if I have 4 of them here and 2 of them over here, to take the same amount away from each, the most I can take out is 2, so an x squared. And with the y's, again, 5 of them here. And 8 of them over here, oh my goodness. There we go. But now when I look at it, I say, okay, I got to take the same amount away from each. That's a y to the 5th. And now divide it out. I say, okay, 15 divided by 5 is a 3. And then when I think about the removal of the x's, again, if I take 2 x's away from each, you notice I'm left with an x squared for that first term. If I take the same number of y's away from each, the y to the 5th, take all those away and I take all these away, you notice I'm not left with any y's for that first term. Okay? The next one, 25 divided by 5 is a 5. I'm not left with any x's, but right here I'm left with 3 y's, so it's y to the 3rd. Okay? And really, again, it's division, so that's why we're taking away, we're subtracting the exponents. All right? And then the last one here, when I look at the 2, the 5, and the 13, there's nothing that divides evenly. When I look at the variables, they don't have any variables in common, which means I can't take any of the variables away. And since they have nothing in common in terms of numbers, and they have nothing in common in terms of variables, I say it's prime. Okay? And it's prime because the only thing I could divide out is a 1, but I don't do that in this situation. Okay? For these guys, it says factor completely. And remember the progression we go through. We look for greatest common factor. Then we count the number of terms. If it's 4 terms, we go right to factoring by grouping. If it's 3 terms, we build a bridge. If it's 2 terms, we look for our special case of difference of squares. Okay? So if I look at this first one, again, greatest common factor, there is none because this 1. Okay? There's nothing I can divide out. So now I look at the number of terms. There's 3 terms, so I build a bridge. Okay? 24 times the negative 1 is a negative 24. So now I need 2 numbers that multiply to a negative 24 but add to a positive 2. That's going to be a positive 6 and a negative 4. All right? I can't use my shortcut for factoring trinomials on this one because I have a 24 out front. Remember, you can only use the shortcut when you have a 1. So I rewrite the middle term. So I have 24x squared. Instead of a plus 2x, I write a plus 6x and a minus 4x. Okay? I replace that 2x with the 6x and the minus 4x. Okay? I replace it with something that's equivalent, but now I have 4 terms. Now I do factor by grouping. Out of that first group, I can factor out a 6x. Oh, didn't write down the x. When I divide that out, that leaves me with a 4x plus 1. Again, whenever you divide something by itself, it's 1. So 6x divided by 6x is a 1. Out of the second group, I have to factor something out. So I'm going to factor out a negative 1. That leaves me with a 4x plus 1. And I've accomplished the goal of getting the same thing in the parentheses. That's what I wanted. So now my 2 factors are the 6x minus 1, the stuff that's on the outside, and then the 4x plus 1, that thing that I have on the inside of each. Okay? And that's my factored form. Next one, I look for greatest common factor. There is none, but there's 3 terms, so I build a bridge. So I build a bridge, 2 numbers that multiply to a 36 but add to a negative 13. looks like it's going to be -9 and a -4. Okay, I just had to think about that one for a little bit. Didn't come right to me. So anyway, can't use my shortcut, so I've got to split up the middle term. You know, and probably the toughest part about these is coming up with those two numbers. Okay, but really, you know, just start doing a little guess and check if you're not sure. Okay, and then the sign of the thing also helps. You know, when you have a positive 36, these each have to be negative or they each have to be positive. All right. When you had a negative before, one of them had to be negative. Okay, so I split up the middle term. Instead of a negative 13x, I replace it with a negative 9x minus 4x. And now I do my factoring by grouping. Out of that first group, it looks like I can factor out a 3x. And when I divide that out, it leaves me with an x minus 3. Out of the second group, I can factor out a -4. And really, anytime I see a negative in front of this term, I'll factor out a negative. But that leaves me with an x minus 3. Just be careful with your signs. And I've accomplished the goal of having the same thing in each of the parentheses. So now my two factors are the 3x minus 4, that's the stuff on the outside, and the x minus 3, which is the stuff on the inside. Okay. Next one, again, I look for greatest common factor. There is none, but there's three terms, so I go right to building a bridge. Two numbers that multiply to a positive 16 but add to a -8 are a -4 and a -4. This time I have a 1 out front, so I get to use my shortcut, which means I can go right to the two factors using the two numbers I just came up with. So it's an x minus 4 because of the -4, and then an x minus 4 because of the other -4. Okay? And if you write this as an x minus 4 squared, that is also, I'll accept either one of these answers for right now. Okay? If I look at the next one, again, no greatest common factor. There's three terms, so I build a bridge. 1 times a -30 is a -30. Two numbers that multiply to a -30 but add to a positive 7 are going to be a positive 10 and a -3. Once again, I get to use my shortcut on this one because it's a 1x squared, so when there's a 1 out front, I can go right to the two factors, so it's going to be an x plus 10 because of the plus 10, and an x minus 3 because of the -3. That is an ugly looking 3. Let me try again. There we go. And that's it. I go right to the answer, all right, using that shortcut. The next one, again, always look for greatest common factor first. This one, there is a greatest common factor. It's a 2, so I factor a 2 out. Leaves me with an x squared plus 4x minus 32. And now I kind of take this thing, maybe I'll take it off to the side here. But if I had x squared plus 4x minus 32, I want to try to factor that further. Well, it's three terms, so I build a bridge. I build a bridge that's a -32. Two numbers that multiply to a -32 but add to a positive 4. Going to be a positive 8 and a -4. And see, I get to use my shortcut in this one because it's a 1x squared now. And so this guy would factor into an x plus 8 and an x minus 4. So if I come back over here to my original problem and say, hey, this guy is now an x plus 8 and an x minus 4, that 2 just kind of stays on the outside, and this is my final factored form. Okay? The next one, again, I always look for greatest common factor first. I don't see any here, so I go right to factoring. And since this one is 4 terms, I'm going to go right to factoring by grouping. Again, the number of terms kind of gives away how you want to approach this thing. 3 terms are building a bridge. 4 terms go right to factoring by grouping. 2 terms, we look for the special case. So then out of this first group, I can factor out a 4x squared, it looks like, which leaves me with a 2x minus 3. Out of the second group, I can factor out a 5, which leaves me with a 2x minus 3. And now I've accomplished the goal of the same thing in each parenthesis, so it's a 2x minus, sorry, I've been writing the other ones. I've been writing them all the other way. It doesn't matter which way you write it. Maybe I'll do it that way. So the 2x minus 3 is the thing inside. The 4x squared plus 5x is the thing outside. Again, the order doesn't matter. The more consistent you are in terms of the order, the more likely you are to write it down correctly, but yeah. The next one, again, greatest common factor, there is none. So I start looking at the number of terms. There's 2 terms. I look for a special case, and I should notice that 81 is a perfect square, x squared is a perfect square. This is a difference of squares. Remember, difference of squares always factors into conjugates. So it's one's a plus, one's a minus, and really it's the square root. Square root here is an x. The square root of 81 is a 9, and then one's a plus, one's a minus. They factor into conjugates, and that's our difference of squares shortcut. Okay? The next one's interesting. It's here to kind of fool you a little bit because it's already a difference of squares. 4 is perfect, 16 is perfect, x squared is perfect. I could go right to conjugates, but always look for the greatest common factor first. This one has a greatest common factor of 4. If I factor that out, it leaves me with an x squared minus 4. Well, now I still have a difference of squares in the parentheses. So this is still going to factor into conjugates. The square root of the x squared is the x. The square root of 4 is a 2. And now 1's a plus, 1's a minus. Okay? If you go right to factoring this as a difference of squares, that's good. That's a good first step. But you're going to have a greatest common factor stuck in each of those binomials that you have to remove. Okay? The next one, if we take a look at this guy, the first thing we want to do is factor out the greatest common factor. So I'm going to take out the greatest common factor. I've got a 7x for the greatest common factor this time, which leaves me with an x squared minus x minus 6. All right? And now if I take that thing in the parentheses off to the side, x squared minus x minus 6, this is a trinomial. It's 3 terms, so I build a bridge. That gives me a negative 6. 2 numbers that multiply to negative 6 but add to a negative 1 or a negative 3 and a positive 2. And now I get to use my shortcut because it's a 1x squared, so I get to go right to the two factors of an x minus 3 and an x plus 2. But now I come back over to the original problem. I have that 7x. This trinomial has now become an x minus 3 and an x plus 2. So that's my factored form, and I'm done. Okay? The next one, no greatest common factor. So I go right to factoring by grouping. So out of the first group, we can factor out an x squared, which leaves me with an x minus 2, it looks like. Out of the second group, I can factor out a plus 4, which leaves me with an x minus 2 as well. And so now I have accomplished goal, the same thing in parentheses. So outside I have an x squared plus 4. Inside I have the x minus 2, so those are my two factors. Okay? And some of us might look at the x squared plus 4 and think, oh, I can factor that further, but you can't. You can only factor a difference of squares, not a sum of squares. Okay? The next guy, no greatest common factor. There's 3 terms, so I go right to building a bridge. So 2 numbers that multiply to a positive 10 but add to a negative 2. As you start to work through your factors of 10, you're going to find out that there's nothing that can make this work. And since you can't come up with those 2 numbers, it means you can't factor this one, so this one's prime. All right? And once again, the only thing you can divide out of each of those is a 1. That's what makes it prime. All right? Next one, again, we look for greatest common factor first. That's a 3. Leaves me with an x squared minus 6x plus 9. And again, if I take that off to the side, the x squared minus 6x plus 9, if I build a bridge, that's 2 numbers that multiply to 9 but add to a negative 6 or a negative 3 and a negative 3. Because it's a 1x squared, I have a 1 out front, I get to use my shortcut. So it's right to an x minus 3 times an x minus 3. That was not a very good set of parentheses. Let me try again. And so now when I come back over here, it's 3 times x minus 3 times x minus 3. Okay? Or you can now write it as 3 times x minus 3 squared. And just understand that those are the same thing. So either one of these is an acceptable answer. Okay? If I take a look at the next one, a square painting is surrounded by a frame. The outside edges of the frame are x minus 5 inches in length, and there is a 6-inch border between the painting and the frame. What is the total area of the border? Okay, and so really I'm trying to find the area of this white section around the painting. That's my frame here. All right, and the thing is this. So if this is listed as 6 inches right here, by saying it's a 6-inch border the whole way around, that means this is 6 inches. Up here is also 6 inches. Over here is also 6 inches, okay? And so what we need to do is identify the area or the dimensions of the painting itself. And so when you look at the painting itself, and this is probably the trickiest part, the distance from one edge of the painting to the other edge of the painting is basically the x minus 5, but then we're going to take away 12. Okay, and here's why. From here to here is x minus 5, but if I take 6 off of this end for the border, and I take another 6 off of this end for the border, really what I had was x minus 5, but I've taken 6 away from each end. I'm taking away a 12. Okay? And so the dimensions of my picture are now going to be an x minus 17. All right. And so if each of these is a square, you can think of area of a square, it says right there in the problem, as area equals the side squared. Or you can just think of it as length times width, but the length and width are the same each time. And so if I want the border, really I'm just going to get the area of this entire thing and then take away the area of the painting. Okay? And so the area of the whole thing would be x minus 5 squared, or x minus 5 times x minus 5. The area of the painting would be x minus 17 squared, or x minus 17 times x minus 17. And so what I want to do is find the area of each of those and then subtract them. So here I have to do my distributive property. Let me show that. So I'm going to distribute the x to each of these and then the negative 5 to each of these. So that's going to give me an x squared minus 5x. And then when I distribute the negative 5, that's a negative 5x plus 25. Over here, when I distribute, and to switch to my green. So I distribute the x, and then I'm going to distribute the negative 17. So here that gives me an x squared minus 17x, and then minus 17x plus 289. And now from here, I just finished doing each of these, combining some like terms. That's a negative 10x plus 25. Over here, that's an x squared minus 34x plus 289. But now I want to subtract each of these. I want to take these two polynomials and subtract. Well, now this is like the first couple examples we did on this review. I'm going to change subtraction to adding the opposite. I'm going to distribute that negative and make it look like this. Okay? And now it's just a matter of combining like terms. As I combine the like terms, the x squareds cancel out completely. The negative 10x and the 34x give me a 24x. And then the 25 and the negative 289 give me a negative 264. And that's it. So this represents the area of that frame. Okay? The next one is a very similar question. The only difference is they didn't draw the picture for us, and now we're talking about rectangles. So the dimensions aren't the same in each direction. But really, so here's what we have. Here's the situation that's being described. I've got a pool. And around that pool, I have a kind of a walkway or a sidewalk. So this is my pool right here. This is my little waves in my pool, right? Oh, man. I'm such an artist. It's really fantastic. But anyway, as I label these things, so the pool, the dimensions of the pool are x plus 4 by a 2x minus 1. And then dimensions around the outside of the sidewalk are an x plus 5 by 3x minus 4. And so what I have is I have the same situation I had the last time. I have to find the area of the whole thing minus the area of the pool. I have to take away the area of the pool to get the area of this walkway that's around the outside. So I approach it the same way. To find the area of the whole thing, I do just the length times the width. So it's 3x minus 4 times the x plus 5. To find the area of the pool, I do the same thing. I do the 2x minus 1 times the x plus 4. It's just length times width. And then once I'm done multiplying all those things out, then I'm going to subtract those two polynomials. All right? So here I've got to use my distributive property. Distribute to 3x and then distribute to negative 4. When I distribute to 3x, that gives me a 3x squared plus 15x. And then, again, be careful, distribute the negative 4, so that's a negative 4x minus 20. And then combine like terms, 3x squared plus 11x minus 20. And then the next one, I do the same thing. I'm going to use my distributive property. Distribute the 2x, and then distribute the negative 1. Be careful with your signs here. When I distribute the 2x, that's a 2x squared plus 8x. When I distribute the negative 1, it's a negative x minus 4. So that's a 2x squared plus 7x minus 4. And now I want to subtract these two polynomials. I'm going to change subtraction to adding the opposite. And now it's just a matter of combining like terms. So I combine the like terms. That gives me a 1x squared, a plus 4x, and a minus 16. That's what it looks like. Okay? So that represents the area of the walkway. All right? The last one is once again the same kind of thing. This one's a little bit more challenging just because of the nature of the formulas. But we're talking about a donut. So we've got a donut here, and we remove the center to make our donut. And it says that the equation for the diameter of this, if this little piece that was removed is x plus 3, and then the diameter from the whole thing right here to all the way to the outside is an x plus 7. And so really, just like we did with the pool example, I have to take the whole thing minus what was removed to get the area of the donut itself. The thing that's just a little bit trickier here is the equation that I'm dealing with. Okay, so the area of the whole thing would be pi r squared, where the radius is x plus 7 this time. The smaller thing that we're removing from the center would be pi r squared, where r is the x plus 3. And now it's just using my rules with multiplying binomials. X plus 7 squared is an x plus 7 times x plus 7. Over here, this guy is an x plus 3 times x plus 3. But now I'm just distributing. So over here, I distribute the x, and then distribute the 7. That pi is just going to kind of tag along for the ride. When I distribute the x, that gives me an x squared plus 7x. When I distribute the 7, it gives me a 7x plus 49. I combine some like terms. That gives me an x squared plus 14x plus 49. But now I also have to distribute that pi. So that's going to be x, well, let me write it as pi x squared. And I'm just going to leave pi almost like an extra variable in here. So it's pi x squared plus 14 pi x plus 49 pi. Okay? The next one I do the same kind of thing. So here I've got pi. I have to distribute the x and then distribute the 3. When I distribute the x, it gives me x squared plus 3x. When I distribute the 3, it gives me a 3x plus 9. I combine some like terms. That's going to be an x squared plus 6x plus 9. And now I distribute the pi. That's pi x squared plus 6 pi x plus 9 pi. But now, once again, I want to subtract these things. And so I'm going to change subtraction to adding the opposite. And now it's just a matter of combining like terms. Okay, I still have like terms hanging out here. The pi x squared and the pi x squared are like terms. So that's going to give me, let's see, a 2 pi x squared. The 14 pi x minus the 6 pi x is going to give me an 8 pi x. And once again, the variable part, including the pi this time, because we're treating it that way, it doesn't change. And then the 49 pi and the negative 9 pi is a 40 pi. Okay, and that's it. This represents the area. I have, oh, I made a little mistake here. Sorry, that was a negative pi x squared, so that actually cancels out. Sorry about that. Pi x squared minus pi x squared is a 0. So I really just have 8 pi x plus 40 pi, and that's it. Hope this was helpful, and good luck on your test.